Okay, today we're going to be talking about adding and subtracting polynomials, which we have done already, and we're also going to learn some vocabulary that we have maybe briefly talked about, but maybe, we haven't really focused on, and maybe some of these words you've heard in the past, but you may not be too familiar with them. So let's just get started. First of all, if I ever just see a number, no variable behind it, this number is called a constant. That word I have said to you numerous times this year. So a constant is a number, no variable behind it at all. Okay, this column says name based on number of terms. Well, there's just one piece to the problem. There's just one term, and since there's only one term, we call it a monomial. Mono means one, and since there's only one term in the problem, we call it a monomial. Degree is the exponent that the variable is raised to, the highest exponent that the variable is raised to. Since I have no variable in this at all, then the degree is 0. And then this is something I've talked about briefly, but we haven't really done it too much. It says arranged in descending order for x if possible. Well, there's only one thing to write, so there's no descending order, but I'll show you what I mean in the next problem. Okay, looking at this next expression. Since I have two terms, I'm going to start with that. I've got 1, 2. Two terms. That is called a binomial. Like a binomial, it has two parts, like a bicycle has two wheels. So a binomial has two parts to the problem. Okay, the highest exponent that we see is a 1. You just don't actually see it. So the x is raised to a power of 1, and so this is said to be degree 1. And when the degree is 1, then this is said to be linear. When the highest exponent is a 1, then we have a linear function, a linear equation. Okay, this time I can arrange it in descending order. So that means you want to start with your highest exponent and go to your least. So my highest exponent part is the negative x to the 1. I just don't have to write it. And then that's a positive 4, so I write plus 4. This is the actual correct way of writing these problems. You want to start with your highest exponent to your lowest. Okay, looking at this next one, we've got 1, 2, 3. 3 parts, so that's called a trinomial. Like how a tricycle has 3 wheels, a trinomial has 3 parts. Okay, the degree is the highest exponent that our problem is raised to, and the highest exponent is a 2, so this is degree 2. And since it's degree 2, this is quadratic. So when the highest exponent's a 2, we have a quadratic equation or a quadratic function. Okay, putting this in descending order, I start with the highest exponent, so I start with the x squared to the lowest exponent. So then I go to the exponent of a 1, so that's a positive 7x, so I write plus 7x, and then that's a positive 3, and there we have written it in descending order. So I started with the highest exponent, went to the lowest exponent, down to the constant. While we're here at linear and quadratic, let's talk about their parent functions really quick, because this is something that you guys really do need to know. The linear parent function, what is it again? Y equals x. And the quadratic parent function, how about that one? Y equals x squared. Y equals x squared is the parent to all x squared problems. Y equals x is the parent to all x problems. Okay, linear graphs make a line, quadratic graphs, those make the U, the parabola. Okay, this next one, we've got 1, 2, 3 parts, so this is another trinomial. But this one's different than the others. If we ever have a mixture of letters, then we don't have a degree. So I'm going to put NA for not applicable. So I can't name it over here based on its highest degree. So we have a degree when the problem only has x's or only has y's. So since this problem has a mixture of x's and y's, we don't have a highest degree for this problem, and I can't give it a special name. And then the same thing with the descending order. If there's a mixture of x's and y's, then there really isn't a proper way of writing it. So I'm just going to go ahead and I'm going to rewrite it the way it was. There is not a proper way for writing it when there's a mixture of letters. So we'll just keep it like that. Okay, our next one. We've got 1, 2, 3, 4, 5 parts. Anytime we have 4 parts or more, we just call it a polynomial. So when there's 1 part, it's a monomial. When there's 2 parts, binomial. 3 parts, trinomial. And 4 or more parts, we just call those polynomials. Okay, the degree. This time it applies. My problem only has x's in it, so what's the highest exponent that you see? 4. So our degree is 4. And when the highest degree is 4, this is actually called quartic. Okay, this one I can put in descending order. So I start with my highest exponent. My highest exponent is this negative x to the 4th. So don't forget about the minus in front of it. So negative x to the 4th. Then the next highest exponent is the x cubed, and that is a positive 6x cubed. And then the plus x squared would be the next highest. Then the plus 8x would be the next highest. All the way down to the negative 9, which is the constant. And there it is in descending order, starting with the highest exponent to lowest. Okay, this next one has 1 term, so that is called a monomial. What's the highest degree? The highest degree is a 1. You just don't see it. And whenever the highest degree is a 1, remember we call that linear. And negative 5x is the only thing that the problem has, so negative 5x is all we can do for descending order. Okay, this next one has 1, 2, 3 parts, so we call that a trinomial. Like our tricycle has 3 wheels. And this one, I have a mixture of x's and y's, so I do not have a degree here. I'm going to write not applicable. And I really don't have a correct way of writing this. So I'm just going to rewrite it the way it already is. And because there's a mixture of x's and y's, I don't have a special name for it. One other thing I did want to talk about, just in case any of you are wondering, whenever the highest exponent is a 3, we call that cubic. So whenever the highest exponent is a 3, we call that cubic. We didn't have any like that in the chart, so I just thought in case any of you wanted to know, there it is. Okay, a polynomial is something that we typically use whenever the problem has 4 or more terms. Like up here, this one had 1, 2, 3, 4, 5 terms, so we just call that a polynomial. A binomial has exactly 2 terms. like 4x minus 2. A trinomial has 3 terms, and that's something like 2x squared minus 3x plus 1. The degree is the highest or biggest exponent, however you like to think of that, the highest exponent or the biggest exponent when there's only one variable. Okay, so the degree is the highest exponent or the biggest exponent when there's only one variable in the problem, which is what we were practicing up above. Okay, I'm not going to worry about ascending because we typically never put our problems in ascending order, so I'm not even going to worry about that. Descending, that's how we typically want our answers. And this is highest exponent to lowest exponent. And I'm just going to write EXP for exponent. I'm sure you guys don't care if I abbreviate. So descending order is highest exponent to lowest exponent. For example, 7x to the 4th minus 3x to the 3rd minus x squared plus 5. This is an example of something that is in descending order. I start with the highest exponent and I go all the way down to the lowest exponent. And I didn't have an x in this problem at all, so sometimes you don't have all of the pieces in the problem, but as long as it goes from highest exponent to lowest, that is the order we want to put our answers in, and that is called descending order. Okay, so this page was a lot of terminology, a lot of vocabulary. Let's practice some problems. Okay, so we're going to be adding and subtracting in this first set of 4, and that's something that we've already been working on, so that shouldn't be any big deal. So first thing I want to look for is, since you see the parentheses, if there's anything to distribute. Is there anything to distribute here? No. Is there anything here in front of this second set of parentheses to distribute? No, nothing other than a positive 1, but distributing a positive 1 doesn't change anything. So these parentheses, they have no meaning whatsoever. Pretend they're not even there. Just start combining like terms. So since this problem has nothing but x's, let's start with the highest exponent. And what is 2x squared plus x squared? 3x squared. Remember, this x squared here has a coefficient of a 1. So all I do is I add the 2 and the 1, which is 3. And when adding and subtracting, never change your exponents. If it starts x squared, it ends x squared. Now let's combine the x's. What's a positive 3x minus 5x? A negative 2x. And then let's do the constants. What's a positive 2 minus 5? A negative 3. And then I just want to practice some vocabulary here. Since the highest exponent is a 2, we call this quadratic. And since there's 3 parts to the problem, 1, 2, 3, we call this a trinomial. This is a quadratic trinomial. Okay, number 2. I've got a bunch of parentheses, so let's look to see if we have anything to distribute. Anything here to distribute? No. Anything here? Nothing other than a positive 1. Anything here? Nope, nothing other than a positive 1. So the parentheses mean nothing. Pretend they're not even there. Since this time I have a mixture of p's and q's, it really doesn't matter what I start with. I'm just going to start with the p's. So I'm going to combine all my p's together. And what is 2p plus 3p plus p? 6p. And then let's combine all of our q's. What's a negative 5q plus 6q minus q? And what do you get? Negative 5 plus 6 is 1. 1 q minus q is 0 q's. There's no q's at all. So all we're left with is 6p. Okay, my highest exponent is a 1, so I can call this linear. And since there's only one term, I call this a monomial. A linear monomial. Okay, this next one, I see parentheses, so let's see if there's anything to distribute. Anything to distribute here? Nope. Anything to distribute here? Yes. Distributing a negative or distributing a negative 1 does change things. So I'm going to recopy the 3a minus 5. I'm going to go ahead and drop the parentheses because they're not necessary at all. And let's distribute the negative 1. What's negative 1 times 5a? A negative 5a. What's negative 1 times positive 1? A negative 1. And now I'm going to combine like terms. So I'm going to start with my a's. What is 3a minus 5a? A negative 2a. And then let's combine the constants. What's a negative 5 minus 1? Negative 6. And that's my answer. My highest exponent is a 1, so I call this linear. The problem has two pieces to it, 1, 2, so I call this a linear binomial. Are you guys having fun yet? I hope you're all awake. I hope you're all behaving. All right, number 4. I've got parentheses, so let's see if there's anything to distribute. Anything out here to distribute? No. Anything right here to distribute? You betcha. So let's go ahead and distribute that negative 1. I'm going to recopy everything in the first set of parentheses. I don't need those parentheses anymore. They were never necessary. Now let's distribute. What's negative 1 times 6xy? A negative 6xy. And what's a negative 1 times a negative 2x? Positive 2x. Okay, this one has a mixture of x's and y's, so it really doesn't matter what I start with. I'm going to start with xy's. So here's an xy and here's an xy. I only can add and subtract things if they look exactly alike. Same variables, same exponents. How much is 9xy minus 6xy? 3xy. Okay, do you see any other y's besides this one? Nope, so I'm just going to recopy it. And then let's combine our x's. What's a negative 2x plus 2x? 0, it's gone. Okay, so this is all I'm left with is 3xy plus y. I can't name this based on its highest exponent because there's a mixture of letters, but how many pieces does the problem have? 1, 2, so I can call this a binomial, just to practice our vocabulary. Okay, moving on to number 5. It says the perimeter of the rectangle shown is 16a plus 2b. What's its length? Okay, you probably could do this without a formula. I'm just kind of big on formulas. And whenever I have a perimeter of a rectangle, I could just add this side plus this side plus this side plus this side. I could do that. Or I could use the formula 2 times the length plus 2 times the width. So I know a lot of you, when you're finding perimeter, you just add this plus this plus this plus this, which is fine. I'm not saying you can't do that. I just want to practice the formula. Okay, so since they told me that the perimeter is 16a plus 2b, I'm going to put the 16a plus 2b right there into the perimeter. So 16a plus 2b equals, and then it wants to know what's its length. So I'm just going to keep the 2L plus 2 times the width, and we actually know what the width is. The width is 5a minus b, so I'm going to put that where the w was. And now I'm going to work out this equation. So the perimeter went into the p, the width went into the w, and I'm going to solve this equation for L. So let me just go ahead and circle everything smushed with my L, and I'm going to start getting rid of stuff that's around it. So first thing I need to do, though, is distribute. I can't have these parentheses in my problem, so let's distribute that too. So the 2L is going to come down. 2 times 5a is 10a. 2 times a negative b is a negative 2b. And then I'm just going to recopy the 16a plus 2b. Once again, if I circle everything smushed with my L, whatever's outside the circle I'm going to add or subtract. And I'm actually going to get rid of both of these things at the same time. We're typically used to only moving one thing at a time. Today I want to move two things at a time. So I'm going to move the positive 10a by subtracting it. And if I subtract it from that side, I have to subtract it from this side. Notice I write it under the a because those are the like terms. And then I also want to get rid of this negative 2b. How can I get rid of the negative 2b? Add 2b. And if I add 2b on this side, I have to add 2b on this side. So we're not really used to moving more than one thing at a time, but it's a good day to try something different. So on this side, 10a minus 10a is 0, shoop, gone. Negative 2b plus 2b is 0, shoop, gone. The 2l is going to come down. I'm running out of room, so I'm going to write it over here. The 2l comes down, and then this side I need to add up. What is 16a minus 10a? 6a. And what's 2b plus 2b? 4b. Remember, I'm still trying to solve for L. So to get L by itself, how do I get rid of that little 2? I divide by it. So I'm going to divide the left side by 2, and I'm going to divide the whole right side by 2. So 2 divided by 2 is 1, so all I'm left with is 1L equals, and then what's 6A divided by 2? 3A. What's 4B divided by 2? 2B. And there's my length. And I probably could have done this problem different ways, just kind of thinking about it, but I wanted to practice our formulas, and I wanted to practice plugging in and actually solving an official equation. Okay, number 6, last one. Are you still there? You still awake? Bear with me, we're almost done. I think now's a good time for a smiley face, right? Smiley face! Okay, number 6. Says find the area of the shaded region if the area of the total region is 6x squared minus 2xy plus 3. Okay, so if I wanted to find just the area of this shaded region, the way I would do that is find the area of all of this whole big rectangle. But that's too much area, so then I'd have to subtract the inside one that doesn't have shading at all. So that's my game plan. If I wanted to find the area of the shaded piece, so if I wanted to find just this shaded piece, I'd find the area of all of it, the whole big rectangle. And I'm just going to call it the big. And then that would be too much area, so I would have to subtract the area of the small one that doesn't have any shading. Hopefully that process makes sense to you. So like number 5, I want to practice using a formula. I want to practice plugging in things that we know. Okay, since it tells me that the area of the shaded region is this, then I'm going to put the 6x squared minus 2xy plus 3 into where the area of the shaded is. Oh, I just did that wrong. I'm so sorry. It says find the area of the shaded region. That's what I'm trying to figure out. I'm trying to figure out the area of the shaded region if the area of the total is this. Okay, this is the area of the total. This is the area of all of this. I'm so sorry. Okay, so this right here is still area of shaded equals. Okay, so area of big. Area of big is all of this, and that's what they mean when they say the area of the total is this. So the area of the big is 6x squared minus 2xy plus 3. And then I'm going to subtract the area of the small. So let's just go ahead and take a second and figure out what the area of this small region is. So I'm going to do that over here. The area of the small, remember we take length times width. So I'm going to take my length, which is 2x plus 3y, times my width, which is 2x. Okay, I need to distribute the 2x. So how much is 2x times 2x? 4x squared. And then how much is 2x times 3y? 6xy. Do make sure you put your letters alphabetical. So we want the x first and then the y. Okay, so that was the area of this little small region. Length times a width. So I want to subtract all of this. So I need to put parentheses around this right here in order for all of it to get subtracted. If I didn't use parentheses, the only thing that would get subtracted is the 4x squared. But I want to subtract the area of this whole entire small rectangle. So I have to put parentheses around all of this answer so it all gets subtracted. Okay, the first part I'm just going to recopy. I have nothing to do with it as of yet. And now I need to distribute this negative, or you can think of it as a -1. So let's go ahead and distribute that. What's -1 times 4x squared? A -4x squared. What's a -1 times a positive 6xy? A -6xy. And now I want to combine like terms. So it doesn't really matter which one I start with because I have a mixture of x's and y's, but I'm going to go ahead and start with the x squareds. So how much is 6x squared minus 4x squared? 2x squared. Now let's combine our xy's. How much is -2xy minus 6xy? A -8xy. And then I don't have another constant besides that +3, so I just bring down the +3, and that is the area of my shaded piece. And we're done here. Okay, your assignment is going to be this worksheet right here. It says assignment intro to polynomials and add/subtract. So that's what I need all of you to work on right now. And then tomorrow I'll have a video that goes over this worksheet and you can see how you did with it. So right now for the remainder of class, I need you guys to be working on this worksheet, Intro to Polynomials and add/subtract. Help each other, but work on it. Thank you.